Okay, let's get started. Can you guys all get your notebook and also your homework as well, because I'm going to check that. Try these two problems on your notebook. We are just simply going to convert those two sequences into explicit and recursives. On a B day in particular, I'm going to make sure that it does not fall under an A day. We have been talking about explicit and explicit formula for sequences for a long time. Well, not a long time, but for like a week. And this week, we are going to involve series because the topic is called sequences and series. So we're going to be talking about both of those two things, and then we're going to take a quiz on that. Quite possibly, most likely, I'm pushing it to next Tuesday because next Monday is like a half day. We could do like a Kahoot or something, and then do a Tuesday, and then we could just like, just get that quiz over with. I was thinking Thursday, but Thursday I feel like it's too short. So I still have a couple things. The more I can teach, I want to teach you. I want to make sure that the review packet's out of the way before I can actually give you the assessment. Okay. So please have that in mind when you guys sometime on the next B day, it's going to happen, the assessment. Just have a habit of just writing the first one first, and then explicit formula. Recursive means I need you to tell me what the first term is. And then got it. I need you to tell me the first term. Recursive, you're always like this. You can tell me the first term and then tell you the first term. For this one, given the explicit, I'm only trying recursive. I need you to tell me a sub n. So at the top, you say a sub what is 7. The first term is 7. You know, got it? Okay, so I need two things like the recursive one. Okay. Schoology. Yeah, just upload it for me to school. When I ask you to write down first term and then the so the regular explicit is just one line, right? But if I ask you recursive, like even for those, I need to tell me the first one is the first term is not. Then you have to guys, for homework questions here, I don't know why I see so many of this. You guys just have one line for this. You can't just tell me a sub n is a sub n minus 1 times plus minus divided by something. You gotta tell me a sub 1 is 9, and then tell you need to tell me two things like that. Okay, that's what recursive formulas are. For the recursive? Yeah. Okay. And then for the next page. All right, same thing. Okay, you did do that. That's fine. You have all the questions. Have it printed out. Yeah, I want to see it. Okay, that's next time. Okay.
Mr. Kim,
Yes.
Carly just wanted to let you know that she's in the waiting room right now.
Oh, I have let them in, I think.
Oh, okay. Thanks, Mr. Kim.
Yep. Okay, so let's take care of the explicit formula for both explicit and recursive formula for this. First, tell me if this is arithmetic or geometric here. Can I start with Wyatt?
This is
And then explicit.
8 sub n is 9 minus 2 times n.
That's perfect. And recursive, please.
A sub 1 equals 9, and a sub n equals a sub n minus 1 minus 2.
-1, -2. Okay, good. So two things like this. I require that for every recursive formulas out there. We also talked about the benefit of explicit and recursive formulas that we talked about this briefly. Recursive is you keep on plugging in the previous term over and over and over and over again. So it makes like a loop, gives you a sequence of numbers that way. The benefit to recursive formula is always that you can sometimes represent a sequence that's neither geometric nor arithmetic into recursive. Whereas explicit, you can kind of locate that one term super quickly, like a sub 207 term. You can use the explicit to figure that up right on the money. Next one here, Jack. Is this arithmetic or geometric? Okay, so explicit. Excellent. And then your recursive. Times -4. Excellent. So very easy stuff. Okay, so this was brief overview of what we talked about on Friday. Explicit versus recursive. What's the benefit? What's its use? And how to represent the same sequence in two different formats, like Fahrenheit and Celsius, right? This entire week is going to be about series. Okay, as the name goes, the nomenclature is sequences, in which we talked about last week. And now it's called series. When I say sequences, I want you to think of lists, and series, in which what we're going to dive into is something that I want you to think of it as adding everything up. It's just much more, I would say, complicated in terms of like what you need to do, because you do need to use your explicit formula background knowledge to be able to solve questions like these guys. Okay, so probably the entire week is just going to be about series, and the quiz most likely happen next Tuesday will be on sequences as well as on series. Let's do a brief history lesson. I know that I don't give you a lot of history lessons in the class here, but there's this guy named Carl Gauss, okay? And for those of you who are planning to go into anything that's STEM field related and you have to end up having to take a lot of calculus classes in college, you'll probably learn about Gaussian something, okay? There's a lot of, so many things out there. There's only a handful of mathematicians you have to know off the top of your head. One of them is Gauss, okay? I'll read this out loud for you. In the 18th century, a teacher asked this class of elementary students to find the sum of the counting numbers 1 through 100. See, I was told the same story too when I was taking computer science course. See, now, from my version of the story is that this particular student was in trouble and he was in like a detention. You know, one of those things where you go into detention, you have to say, I will not swear, I will not swear. You saw it like on Simpsons, like they have to repeat that. So like it's a tedious work to give them as a punishment. So this was their punishment, adding 1 through 100. But my version was that it was adding to 1 to 1000. Obviously, that's going to take a long, long time. A pupil named Carl Goss correctly answered within seconds, astonishing the teacher. Now, I'm just going to go with the context that was given. If you ask any elementary school students that's 7, 8, 9 years old, now let's rewind back the clock about, I'd say 6, 7, 8 years ago. If I was giving you the same question, what would you guys most likely do if I ask you to add 1 through 100? Yeah? Just start listing them out, right? 1 plus 2 plus 3 plus, you know, this as any normal kid would do. But to go to all the way to 100 would be very tedious for 7, 8, 9 years old. Managing to solve this within seconds, now that sounds a little fishy, but astonishing the teacher, Goss went on to become a great mathematician. He solved this problem by using something called arithmetic series. Now, hence the word series, I told you before, it was adding up all the numbers. Arithmetic because it's 1, 2, 3, 4, 5. Okay? Now, obviously, if I were to ask you as a high school student, doing this by counting is going to take a long time. You might have been faster compared to 6, 7, 8 years ago, but you will still be, it will still take you a long time. There's a really neat trick to how to solve this, and I'm going to skip the middle boring stuff, and I'm going to go straight to the first 5 numbers and the last 5 numbers, and there's a specific reason as to why I'm showing you this. Okay? So 1 plus 2 plus 3 plus 4 plus 5, blah, 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 all the way to 96 plus 97 plus 98 plus 99 plus 100. For every arithmetic series out there, take a look at the very first term and the very last term that's given to you, okay? And let's say that I'm going to add those up because we're talking about series. Can someone tell me what 1 plus 100 is? 101. Yay, that was not that bad, right? Okay, so that's 101. Now there's a pattern I hope you guys notice. The second to the first number added with the second to the last number, what's 2 plus 99? 101. See where I'm going with this? If you keep on taking these sums of the first and the last, they give you the same thing over and over again. And what's more is that, okay, so then all you really have to count is how many 101s you have. How many do you think I will have in this type of sequence here, yes? How do you know it's 50? 100 numbers here, and then you're kind of like, hey, get in a group of 2, right? Hey, pick a partner. We take the smallest number, we group up with the largest number. That's one partnership. The second smallest number to the second biggest number. That's another partnership. So it's how many pairs do we get? So like Wyatt said, we take this 100 and divide it by 2, which is pretty simple, 50. And what do we do with 50 and 101, Wyatt? Multiply. So 1 plus 2 plus 3 plus 4 plus 5 all the way to 100 is 50, 50. Because that's 101 times 50. Does that make sense? Okay. That's how arithmetic series work. All right. So this guy, this clever Carl Goss was able to figure that out. Okay. Which is pretty neat. Now on the, obviously I'm going to give you the formula slide. So here's what I'm going to ask you to write down. This is called partial sum because I'm asking you to find partial of the sequence. You're not adding from 1 to infinity. The summation formula, I want you to write it in this format, please. Please don't write it the way that it's shown in the textbook. The summation, S of n, is equal to n divided by 2, which is the number of numbers divided by 2, how many pairs I have, times the very first term, a sub 1, plus the very last term, a sub n. For example, the summation of the first 100 numbers in the sequence I provided for you in the previous slide was 100 divided by 2 times 1 plus 100. That's how you would plug the numbers in there. So in any case, you need 3 components. You need n, the number of numbers, the first term, and the last term. By having those 3 components, having those 3 ingredients, you can solve for any series that you want, as long as it's arithmetic. Yes, Ronit? Geometry, maybe. I don't know if that's what you're talking about. Yeah, because if you're dividing by something, instead of adding or subtracting, most likely be geometry. Yeah. Oh, are you talking about like midterm formula? Like you're adding those two and then divide it by 2?
No.
Is this what you mean? Okay, never mind. Okay, I'm assuming I can move on, so I'm going to move on. Okay, right? Okay, so, all right, here we go. Find the sum of the following arithmetic series and write it in summation notation. Please ignore this because the summation notation we're going to get to. It's a fancy little thing called Greek symbol called sigma. We're not going to do that yet. I just want you to practice series. So 4, 11, what is that? 18, 25, blah, 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 to the first 16 terms. Find the partial sum of that. So I want you to tell me S sub 16. 3, don't think of it as a fraction, please. Let's write it in a decimal. 8.5, I'll give you more numbers. 14, 19.5. And then first 20 numbers, so it's S sub 20. Remember, you need 3 things. You need n, which is provided for you. You need the a sub 1, which is also provided for you. You need a sub n. You need those 3 components because the formula is always n divided by 2 times a1 plus an. Yeah.
Wait, so are we given a sub 1?
Yep.
And
You
then-
are.
Yeah. I was just making sure. And
Oh, yeah.
then- But what about a sub n?
Ooh, good question. Am I given a sub n, guys? Nope. So what are we supposed to do?
So,
Solve it by using what we know from last week.
done.
That's why sequences have to come first. We talked about this last week. Arithmetic sequence. Nope, 16 is a term number. Okay?
Oh,
So what's happening here is that this is my first, second, third, fourth. I need you to go 5th, 6th, 7th, 8th, 9th, 10th, all the way to 16th term, but you're not going to keep on adding 7s, are you? You're going to use the explicit formula. Can you actually do this? Do you have a calculator with you? I'm just going to assume for those of you who don't have a calculator out, either you're really super good at mental math or you're not getting it. Your n. You're right. You put a sub n here. That's it right there. You use the arithmetic formula to just reverse it. Oh, for arithmetic? So how did you do that? How did you come up with that? Okay, so anyway, the explicit formula for the arithmetic is that the very first term of common difference. You have first term, common difference, and minus. Plus the common difference times n minus 1. Let's try this one more time. Wait, we do it right here.
Well, oh, yeah, well, so I didn't want to do this, I found this one, because I realized to get a from home, I'm doing this, right? So once I get it, then I'm going to use.
Plug it right here.
Yeah,
There, and we get
I
it.
just got lost.
Okay. So you're on the right track then.
Yeah.
Awesome. Okay. I'm glad to see a lot of you guys are able to blend in with the explicit formula as to how it relates to solving for series, because I am not going to give you the first and the last term. Sometimes I might give you the first term, and sometimes I will give you probably the middle two. You know, I could ask you for various different ways in which I could solve for it. But at the end of the day, if I ask you to solve for the series, you find all the components that you need, and then you find your answer. For sum of 16, let's take this one thing at a time because we are at that infant stage as to when we're doing this. A sub 1, it's straight in our face. It's 4. The question is, what's a sub n? Okay, Katrina, how did you find a sub n here? Explicit formula, okay. Which is 15, right? There we go. First term, and we can all see the pattern at this point is plus 7s all the time. So that is it. That's why I said if you're good at mental math, go ahead, but why not just use your calculator? And please bring your calculator when you're taking this quiz, okay? Or at home, whichever, whatever you like. That's going to give me, what is that, 109? So 109 plugged in right there, 4 plugged in right there, and then 16 plugged in right there. Katrina, my final answer is 904. I saw 904 in pretty much every single one of your papers, so we're good. All right, next one. The 20th term, a sub 1, a sub n. Andrew, could you tell me what the first term is 3. What's a sub n here? What, 104.5 you said? Okay, so 3 plus 5.5 times 19. I think that's what you did here. Okay, and then 3 and then 104.5. This one will be 20 times 2, and then we have 107.5 here. What did you get for your final answer? 1,105. You said that's what you got? Okay, so that means that I made a mistake then? Wait, this should not be 104.5. It should be 107.5, right? Wait, 107.5, and then it should that should be 110, and then it should be 1,105. Not that bad, right? It's not too much of an escalation from what we had talked about last week. So we're just gonna go straight along. Okay. Jack, let me know when you're done. Okay. All right. On the homework questions, there are only a few of these that looks like this, where now it's instead of me giving you just like sequences, I just give you a bunch of things. Okay. It could be mix and match of various different types of ingredients. Here I give you the last term, the common difference, and I give you the n number. Using the information above and what you know about the explicit formula of arithmetic sequence, it asks you to specifically to find a sub 1. Now, why would I bother giving you that as part 1? Yes, Jacob? Oh, what's up? Yeah. It's exactly because it's different, it's arithmetic, right? Because if you think about it, common difference is what you need for arithmetic. So here, why would I need to have a sub 1? Because take a look at what I'm asked to ask you to solve for part 2. Yes, Daniel? That's right. I provided for you the equation at the top right corner. Take a look what was provided for you. I have n. I have a sub n as well. What am I missing? The first term. But I do give you a common difference to make up for that. So that you have plenty of resources. You have all the necessary ingredients for you to be able to solve for a sub 1 and then use that information to find for me the sum of the 21 numbers. See, I can ask you for these various different types of things. Okay, so go ahead, take a crack at it at this one. Okay, so Grace, did you solve for the a sub 1 here?
Yeah.
Okay, so how did you get it?
I plugged it into a started 135
Which is 20. So what'd you get for a sub 1? That's correct. So now as the 21, all you gotta do is just plug it in, right? 21 divided by 2, 45 plus 145. Your final answer, please. Okay, 21 divided by 2 times 190. I will tell you right away. Yes, Ron? There we go, 1995. 1995. Okay. If you solve for that, then there's no need for you to. Yes, Ron? You mean like x like this?
No, I mean I put 145 into x plus 500.
That's totally fine by me. That's totally fine by me. Okay, let's try another one. Now I'm gonna put a different twist to it. What if okay, and actually, yeah, yes, let's do this one. So I give you the first term, I give you the last term, and I give you the common difference instead. Using the information above, now everyone just don't write, just stop writing for a second, just take a look at that and tell me which one am I missing for the summation formula and over to a sub 1 plus a sub n that I should be looking for, Jacob? And because I have the first and the last term, I just don't have n. So I need to solve for that somehow. Again, I make up for that by providing you with the common difference, okay? So use the explicit formula. It's going to be used a lot for series. Use it, get the n value, then please tell me what the partial sum is. S of n. What's the n number here that you found? 15. Okay, what's I just get 12n. Yeah. Good. Try this again. N cannot be a decimal. Because think about it. 1, 2, 3, it's like staircases. You 1, 2, 3, 4, 5, 6, 7, 8. You can't have a 10.75th of a term. You either have a 10th term and the 11th term. Okay? So here you have 12 plus 4, but you thought this was adding together, but this 12 plus 4 times this whole thing. You don't add these two things combined. Okay? You have to subtract the 12 away first.
Oh, okay.
Okay?
Like this 4 times 8 minus 1.
Right. That's 4 is only applied to the parentheses there. Okay, guys, do not make the silly mistake in algebra. If you're, that is not one of the things I want to see. If once I plug into the explicit formula, which all of you guys have done, 188 is equal to 12 plus 4 times n minus 1. There we go. The only letter missing is n. Take it one thing at a time. You subtract 12 first. This is algebra, pre-algebra stuff. This is 176 equals 4 times n minus 1. You divide those by 4. Take it one thing at a time, order of operations, that kind of stuff. This is 44 equals n minus 1. N should be 45. Plug it in. You should get a partial sum of 4,500. Let the calculator do the work for you. Okay? Not that bad stuff, right? Okay. Why do I have 8 minutes left? Okay. I'm going to ask you to do number 20. And then before you guys go, I need to show you guys some word problems with this. This is a little bit different. Take a look. See, I'm giving you all these different types of scenarios just for you guys to be exposed to these types of questions and how to solve it. I give you the second term in the sequence, and I give you the fifth term. A little more interesting than before, because now what do you need to solve for? I need to solve for both a sub n, and a sub 1. But I do provide you with n is equal to 12. So that's good. Remember, we're just strictly talking about arithmetic right now. Don't even think about it being geometric. Daniel, you have a question?
Like I know what ace 1 is.
What is it?
It's 7.5.
Oh, great.
But I don't know like how I like.
How did you get it?
Yeah.
Well, how did you find that it was 7.5? Well, how do you know the common difference was 0.5?
Because I looked in between 8 and 9.5,
Okay.
and then I tried. It was really just like an educated guess.
Okay, but you're correct. A very good educated guess indeed. But you seem puzzled. That's my question. That's
It's
why.
just
That's
like-
why I'm puzzled.
Is there like an algebraic way, like a formula to get to?
Yeah, we did this for homework. Remember, a sub 2, which is 8, is equal to a sub 1 plus common difference d. We still don't know 2 minus 1.
God. Oh.
Systems of equations. Remember that?
Yeah. God.
Okay, but that's a. You know, you don't have to do that if you can solve for me that quickly.
You don't have to show that.
Okay, well, first of all, I showed you this because I know some students want to have that constructive way. This is very easy, right? But what if I give you like 24th term and the 52nd term? Then you probably do want to use that still, okay? So to answer your question why, just do it for the habit, you know? Just to be ready for some hard questions down the road. Hold on. Good job. Yeah.
I didn't really think if you had one based on this one.
Yep.
I think, 75.
So this is systems, right? So subtract from top to bottom. Forget about these guys, okay? So I'm going to erase this 2. And then I am going to I just like having the higher number at the top like this. So that's what I'm going to do. Now, if you take a look, if I subtract from top to bottom, do you see 9.5 minus 8? What do I get? What happens to a sub 1s? This is 4 times d, because that's 5 minus 1 times d. This is just d here. So what's 4d minus d? How do I get d by itself? What do I get? 1.5 divided. Take your time. Think about 15 divided by 3.
Wait, 1/2.
1/2. Very good. So 0.5 is your common difference. How do I get 7.5 was your question, right? It's really simple to find because, hey, take a look. I'm given the second term of the sequence. So I just have to reverse one more time, which is 7.5. So a sub n here, if you guys use the explicit formula, it should say that a sub n is 7.5 the first term plus common difference times 11, because that's 12 minus 1. By doing that, you should get 13. By doing this, the summation formula, which states 12 divided by 2 times 7.5 plus 13, total of 123. Sorry, I'm rushing a little bit, but that's what the answer is going to be. Last question before you guys go, because I really want to show you at least one word problem before you go, okay? I'm going to ask you to just do number 9 here for me. I'm going to read this out loud to you. So suppose there are 20 rows of seats on a concert hall. So if this is where the concert is being played at, remember the seats are usually kind of like in this arch kind of thing. If you've seen those amphitheaters, right? 25 seats in the first, 27 seats in the second, 29 seats in the third, and so on. I guess you guys can all see what the common difference is going to be. And it says if the price per ticket per seat is $32, how much will be the total revenue of this concert playing that one night? Remember, there are 20 rows like that. No, N is 20. They tell you that there are 20 rows in total. Common difference here should be seats, which is 2. There are 2 seats in addition every single time. That's correct. Well done. Yes.
So what's the 32? Like, I know it's like
Forget about 32 right now. Tell me how many seats there are in total. First, find out how many seats there are in total, and just multiply by 32. Guys, I'm sorry, but I'm gonna rush through these. The 20th seat should be 25 seats in the first plus the common difference times 19. This should give you 63 in total, which I believe that's going to be the correct case. 63 plus 20, and remember, S sub 20, the first 20 row seats combined is 20 divided by 2, 25 plus 63, which should give you, this is 88. So that's going to give you, still going to give you 880. There are a total of 880 seats in this theater. Multiply by $32 because that's going to be giving you your revenue. Total comes to 28 grand and 160. Okay, that's what the answer is going to be here. All right, so homework on this stuff. Remember, it's due tomorrow. And pack your things up and have a great day. What's up?
like I think I know how to do this. I just totally forgot. Like the
Yep.
column before we just did this.
Yeah.
But this one, how do you find AN again? I don't know. I just like what are we doing?
Let me go back to this one. Are you talking about this one? No, you're talking about this one.
Yeah.
Okay, so to find a sub n, you know that the first term, you just use this.
Okay.
Use explicit formula again. So a sub n is the first term, which you found at 7.5.
Yeah. that's-
Common difference here, we found that it was 0.5
Mhm.
times the 12 minus 1 because they tell you what n is.
Oh, that's okay.
And you get 13.5, I think. No,
Okay.
13.0.
Okay. And then you just use 13. Okay.
And then the summation is this.
Okay. Yes. Thank you.
Yep.
All right.
You too.